Okay, so we are looking at problem number 4 on page 571, which gives you some kind of an image like this, and then asks you to find or set up and find a definite integral for each given interval. So part A says write down a definite integral that represents the displacement and a definite integral that represents the total distance traveled for each of the following intervals, and then use the diagram to find these values. So first things first, we want to talk about some of that difference between displacement versus distance again. So displacement, right? If I am moving forward, I count that as positive motion. And if I travel backwards, I'm going to count that as negative. So when I'm looking at the graph, if this is my position graph, then ultimately I'm saying, I started 4 meters. Sorry, so I kind of started at 4 meters per second, so I have like this positive velocity, and then I hit 0, and that's when I stop. But notice that my velocity then becomes positive again, so it's kind of like moving forward and then coming to a stop, and then still moving forward. So the velocity is staying positive there, which means that I'm still moving forward, and what I'm collecting as area here is actually forward motion. Now it's here when I stop again, and then my velocity becomes negative, that's where I'm actually moving backwards some amounts, and I have negative velocity. And so all the area under here represents like distance traveled backwards, and so that will be counted as negative when it comes to my displacement. Okay, so now let's actually start talking about this stuff. Anytime you have an integral, you of course are looking for area under the curve. So I'm just going to start by finding all of these areas to begin with. So here, this is a triangle with a height of 4 and a base of 2. So 4 times 2 is 8, cut it in half. This is 4. So that's like 4 meters that I traveled in that amount of time. Here I have a triangle with a width of 6 and a height of 6. So 6 times 6 is 36. Cut that in half, and you get an area of 18. So I'm just looking at areas of triangles. Okay, this one's a trapezoid. So I'm going to want to take the average of the bases and multiply by the height. That's just the base 1 plus base 2 over 2 times height equation for a trapezoid. So I think of it as taking an average of the 2 bases and multiplying by height. So this here is a base of 2. Between 8 and 14 is 6. So 2 plus 6 is 8. Cut that in half is 4. And then the height of this is 3. 4 times 3 is 12. Now, because the height is technically a negative 3 and all this area is below the curve, below the x-axis, I'm going to say that that's a negative 12. So that's an area of negative 12. So just keeping track of when I want to talk about things as being positive forward or negative backwards. Okay, so first part, A, it says find distance and displacement from 0 to 8 seconds. So I'm going to call big D displacement and little d will be distance. So that's how I'm going to answer each of these. Okay, so from 0 to 8 is just going to be the integral of my velocity function. And if I'm looking from 0 to 8, so 0 to 8, that's both of these triangles. So it would look like an area of 4 plus 18, which is a displacement of 22 meters above where you started. Okay. The distance, however, distance is counted as positive no matter if you're moving forwards or backwards. So this is actually my absolute value function. But of course, all of this motion is in the positive direction anyway. It's all above the x-axis, so it's actually going to be the same. I just have my 4 plus 18 gives me 22. So displacement, I'm 22 meters ahead of where I started, and that is the same amount of distance that I traveled as well. Okay, so part B now changes and says, find the displacement and distance from 2 to 14. So displacement, big D, is from 2 to 14 of my velocity function. Okay, so looking carefully at our graph, I'm looking from the time 2 over here to 14. So I notice that that spans the 18 meters that I went forwards, but then it also includes 12 meters going backwards. So you can even think about this in terms of steps. If you've gone forwards 18 and then backwards 12, well, you really only traveled 6 steps from where you began. Which is different than the distance. Because now if I'm traveling for that amount of time, I went all of those 18 steps forward and then all of those 12 steps backwards. So for distance, I'm counting all of this as positive. How much, did my body actually move? What was the amount of work actually done? So that's more like this, which would give me 30. Okay, last one, part C, wants the entire time interval now. So again, displacement from 0 to 14 seconds, and then distance as well. So from 0 to 14, big D, displacement is just the velocity function itself. So I've got the 4 and the 18 that I went forwards, and then 12 backwards. And so that should give me a total of 10 meters altogether. But the distance that I travel is the absolute value, which essentially means make everything positive. Sorry, I forgot to put the absolute values here as well. But that's making everything positive. So the 4 plus the 18 plus the 12, that would give me 34 meters total. So, it's really just that knowing that your integral is area under the curve, so start with looking at the areas, and then displacement, you can be positive forward or negative backwards. Distance, everything is counted as positive, and that's really the key to this problem.